So now we're going to be looking at distance time graphs. So you should have seen these before, where distance is plotted on the y-axis and time is plotted on the x-axis. And basically what this shows, in this scenario, it shows the distance travelled by this quad bike in a set period of time. So from this question, it's going to ask us, what is the average speed between 10 seconds and 15 seconds? Well, what is the average speed? So basically that's asking us, so we said from the, just before that speed is a measure of distance over time. So we've got distance over time, and we want to know the average speed between these 2 points. So basically what we want to know is the rate of change of distance between these 2 points. And something else that is the same as rate of change is the gradient of a line. That's basically the rate at which this line is changing with the up here. So we already have a formula for the gradient of a line, so it should just work here. So we'll just do that now. So gradient for a line, we should all know, equals m equals y2 minus y1 all over x2 minus x1. So what are our 2 points here? Our 2 points are here where we have 15 up here, and 20, that's not a bit of a push, and there. Okay, and our other point here, that's 10, 10. And I quite like to put the number of the coordinates above it. So that is, excuse me. That is x2, and y2, and that is x1 and y1. So I just plug them into here. So we have 20 minus 10 all over 15 minus 10. So what does that give us? 10 over 5, and that simplifies, it's 2. And we know we're looking at the speed here, so that's 2 meters per second. You can also see that because the y coordinate has units of m meters, and the x coordinate has units of time in seconds. So that's our final answer. So that was pretty easy to work out the average speed there. But what if you have a situation where there's not a straight line between these 2 points? So kind of a similar looking graph here, but obviously the line's a curve. So our straight line formula won't be accurate here. And what if we want to know a time at a specific moment? Well, we want to know the time at 10 seconds rather than the average time between 10 and 15 seconds. How do we work that out? Well, basically the answer to that is differentiation.